Hello to you, Tenfolders. Welcome to another epic edition of your favorite television program. My name is Sibusiso, and as always, I'm very excited to be with you on another eye-opening edition of a show that is proudly brought to us with lots of love by Liberty. A very special shout out always goes out to these people that are not only sponsoring our show, but are also behind an awesome app that is available on your app store that we call the Tenfold Education app. This app is packed with a lot of very useful goodies for you if you're doing grade 10, 11, or 12 or medicine science students. To make sure that you get yourself this. It will actually beef you up with a lot of very useful resources that include exam questions and notes and a lot of access to basically these kinds of things, including this show. You can be able to communicate directly to us and tell us what you want us to assist you with. If you're one person that enjoys learning by watching videos, we do have them as well. We've done a lot of shows before, and we've uploaded them on YouTube. Go there and find us. We are Mindset Learn. Once you're there, please do make sure that you subscribe to our channel. You also like all those videos that we've uploaded for you there that you find interesting. Remember, on today's program, we are looking specifically at the errors and misconceptions that matrics generally make to assist you not to make the same mistakes. We'll be looking specifically at paper 2 concepts. We're looking specifically at the errors and misconceptions that you guys generally make when you are writing paper 2. Now, before we even go far, I want you to understand something very interesting, is that there are 3 things that I want to draw your attention to before we jump into each and every topic or each and every concept that is in your exam. Just generally speaking, number 1, you guys have a problem of making calculation errors. So there's not much that we can do. We're not going to specifically be talking about that on today's program because calculation errors are everywhere. You make a sign error, or maybe you leave out a like term trying to add stuff up, or you multiply incorrectly. Like, we need you to be able to make sure that you get your things perfect. Do not make those calculation errors. They're actually working against you. So that's one of the things that I want you to be aware of. Calculation errors is the first error that we generally find across all topics. The second error is that you guys do not know your basics. So it's important for you to understand and know all the concepts that you're going to be writing on. If I'm talking about graphs, you have to know what is going on with your tree graphs. If you're talking about analytical geometry, you guys have to understand the formula for distance, the formula for the gradient. If you're talking about geometry, you have to know all your theorems and axioms. So this is not necessarily going to say, what do you do if they ask you this question? We expect by this time that at least you have some working knowledge of how to do that. If you don't, always make sure that you follow us either on our app or you go to YouTube. We have done a lot of lessons that can help you to brief yourselves on that. And lastly, maybe the third thing that I want you guys to be aware of is your ability to analyze the love letter. Okay, every question, in fact, in geometry, analytical geometry, and maybe some in stats and some in trigonometry involve the love letter, the opening statement. So that statement is very, very crucial. So what we want you to do is you have to read that thoroughly and understand, highlight all the keywords, take anything that you find useful from the keywords against the diagram and updating your diagram. So your ability to analyze the love letter is very, very important. So do make sure that you do not neglect that. More often than not, we find that there is information that the examiner put in the opening statement, but the matrics are unable to answer a question because they did not take note of that. Okay, so it's very important for you to make sure you read the love letter, you understand the opening statement. Against the diagram, you're able to say, if somebody says to you 2 lines are parallel, there's nobody who just randomly decides to tell you that 2 lines are parallel. When we tell you that 2 lines are parallel, it's because we know that that is going to assist you. So do make sure that you take that into consideration, you make note of that, and then you update in your diagram and you check if we indicate it in the diagram and use that information to answer the question. All right. Now, without any waste of time, we're going to be looking at all the concepts that are involved in paper 2 and help you understand what are the common errors that we have picked up, that we have seen over the years that we don't want you to make and want you to be aware of them. All right. So let's jump into the following breakdown here that tells us the common exam mistakes, errors, and misconceptions that we generally see in mathematics. This are for paper 2 specifically. Of course, in paper 2, we've got data handling, and when you're doing data handling, of course, we've got univariate data, we've got what we call grouped data, okay, univariate and grouped, and then grouped data, and we also have a bivariate data. Very important for you to know those are the topics that we're examining there. Analytical geometry is where we'll give you coordinates and give you maybe quadrilaterals, or we can give you a circle or anything like that. Of course, some questions involve circles, but we have coordinates. The point is about coordinates, and we ask you a lot of questions around these, and we want you to be able to figure out what the answers are going to be. So I hope you are aware of that. And then we've got trig. Of course, trig, what I'm going to write here is just SOHCAHTOA. Why? Because SOHCAHTOA tells us what trig ratios we work with. We've got a lot of questions. Some of them involve trig graphs, okay, and some of them involve the 2D and 3D questions that you get. I think those are questions that involve measurements that about calculating the sizes of sites, the angles that you might have. Those 2D and 3D questions are also examined in trig. And then in geometry, we all know that it's also going to be about angles and stuff, and then we might have the proportionality theorem also playing a role there, and so on. So these are the ideas that we always examine. Of course, measurements can pop up anywhere here, so you have to be aware of calculating area, surface area, as well as volume. We can ask that either in trig, we can also ask that in geometry, but we do not examine it as a standalone topic. So, but it can appear anywhere, and you guys have to be aware of that. All right, now just going to the very first section, we want to look at what are the errors and misconceptions that grade 12s generally do when you're doing data handling. Data handling is what we call stats sometimes. It's statistics. So because you guys are doing stats, there's a lot of calculator work. Okay, calculator work is generally the most biggest problem that we see, because people either have left out the number, somebody is not typing all the numbers in the calculator they're trying to find. Maybe you're trying to work out the mean, which is obviously the sum of all the numbers divided by how many they are, and then you make a mistake or a boo-boo on that. So please be careful. Make sure you do not make any mistakes when you're using your calculator there. That's the number one problem that we see when we ask metrics to calculate stuff that involved ungrouped data. What is the meaning of ungrouped data? Maybe I tell you the height of people, or maybe I give you the marks of kids, okay? I can give you a lot of marks. Somebody got 48%, somebody got 92%, somebody else got 40%, somebody else got 62%. I can ask you a lot of questions on that. Find the minimum mark, find the maximum mark, find the mean mark, find the 5-number summary of these marks, plot the box and whisker plot, all those kinds of things. I can ask you that, so please do make sure that you don't make any mistakes on that. Right, and then in group data, what we generally have is, of course, we'll give you a table that has got certain values. Maybe let's say we're talking about marks here. The lowest mark was 40, so I'm doing 40 to 45, 45 to 50, 55 to 60, maybe 65 to 70, and so on and so on. I think I wrote etc. here, but we can expand this and talk about I think it's 55 to 60, 45 to 50, okay, 50 to 55, okay, and then 55 to 60, right, and then trying to make sure that you guys are able to work with them. Let's just make sure that you guys can see what is going on. But this is generally what we're speaking about when you see you've got marks that are given. We don't know how, we just have intervals here, 45 to 40 to 45, 45 to 50, 50 to 55, and then 55 to 60, and this can continue on and on. We've got this in the table. These are marks maybe of kids, and then we've got the frequency, okay, and then we ask you, maybe we say that 4 kids who got the marks between this range. There's 7 kids here, there's 11 kids here, there's 2 kids here, and so on and so on there. And then we might ask you to draw what is called the cumulative frequency curve. Now you need the cumulative frequency value here, which is what you get when you add all those numbers. You'll have 4 plus 7 gives you 11, 11 plus 11 gives you 22, and then you continue working this out. Now the biggest mistake we see is when we ask you to draw the ogive, okay, the cumulative frequency curve. The very small number is what you get when you take 45 and you merge it with 4. So 4 is a number here, and 45 will be a number here. So your graph will start somewhere here in the middle. So the biggest problem we have is people forget to ground their graph. So where do you have to ground your graph? You have to ground your graph at this number 40 here. That's the smallest number ever that the graph can ever get to. So remember to push it all the way to the ground value. So do make sure that you always ground your cumulative frequency curves if you're drawing them. And then when you're talking about bivariate data, again, the number one problem we see here, the errors include what happens when people try to use their calculator. So calculator work, okay? Calculator, because you just have to take numbers from what is given, because we're going to give you a table, maybe let's just say ice cream sales versus temperature. We'll give you temperature here, and then we give you the sales day one. Let me just put days here as well, because you have to understand, if you're given 3 columns, what exactly are you trying to compare? In bivariate data, we're trying to see what influence does one variable have on another, if it does at all, okay? Day 1, we might have day 2, we might have day 3, we might have day 4. So we have noticed that if I say 20 degrees, we sold 7 ice creams, 27 degrees, we sold 13 ice creams, 4 degrees, we sold 3 ice creams, and so on and so on, right? We can continue on this note. You will have to take this information, put in a calculator, work out the A value, work out the B value, work out the R value, use this to find the equation, okay, of least squares regression. And then this is a correlation coefficient, the mean value for the x values and the y values. But what exactly are you comparing is usually the problem, because people will look at this, they don't know what do I put in my calculator as x values and what do I put as the y values. You will have to figure out, I'll be comparing days and temperature, days and sales, or temperature and sales. And I promise you in this particular question, I'm comparing this, so this will be my x values and this will be my y values. So please do make sure that you understand what is being compared and what you're trying to work with, to make sure that you do not make mistakes. So biggest problem that we have when we're dealing with this bivariate data is that people do not insert the information correctly in the calculator. The second problem that we have in bivariate data is a scatter plot. When you ask for a scatter plot, the scatter plot will be like in this context, 20 is the temperature, which will be on the x-axis. If I say 5, 10, 15, 20, 25, so my 20, which meets 7, on the y-axis I'll have values. Where 20 and 7 meets, I have to put a dot, maybe, or a cross, and then where 2 and 27 meet, okay, 27 and 13. So 27 is temperature here, and 13 will be somewhere here. And then where 3 and 4 meet, okay, that's like you're looking at 4 degrees temperatures, and then the sales are 3, so somewhere here. So once you start putting, this is called a scatter plot. What you're looking at here is a scatter plot. A scatter plot is a scatter plot. Do not draw any line if they're asking only for the scatter plot, okay? So when they ask for the scatter plot, it's only there that you will draw the line of best fit, or the least squares regression line, which has an equation, the equation of which is this one that I spoke about here. You can be able to find it. If you've got your A value and your B value, you can work out exactly what the equation is going to be. And do not draw that line beyond the points that are given in your table, because we do not know what happens after, okay? It is wrong for you to draw it beyond the points that are given in the table, because we do not have sufficient information to predict what's going to happen after as this particular thing progresses beyond what we have worked out, or what we have calculated, or what we have surveyed, okay? So please do make sure that you don't make that mistake. So number one problem, calculator work in this case. And then number two problem is people draw the scatter plot while they're not asked to draw the scatter plot. So do not draw the scatter plot if you're not asked to draw if you asked for the scatter plot, put it there. When they ask for the line of best fit, that's the only time that you can put the line of best fit. If they don't ask for that, don't do it. So do make sure that you understand the differences between the two. Now we're going to go to our second section. This is where we are going to start focusing on analytical geometry. This is part 2 of our paper 2, misconceptions and errors. We want you to understand what are the errors that you are likely to make to help you not to make those mistakes. So without any waste of time, let's jump right into it. Okay, so when you're looking closely at this particular section, which is going to be about analytical geometry and not data handling, very important for us to note that this is actually when you're looking at analytical, right? Analytical geometry. Some people call this coordinate geometry. So what are the errors that you as a matriculate are likely to make when you're writing analytical geometry? So we'll start first of all by acknowledging what do they test. They test distance, midpoint, and gradient. There are formulas for this. Some people copy the formulas incorrectly. Please do not make that mistake. You cannot copy something that you're looking at incorrectly. Don't rush yourself. Do make sure that you copy the formulas correctly. The formulas, okay, that's the first problem that we have. Okay, they are on the formula sheet, right? Available. They are available, okay, on the formula sheet, so you cannot mess them up. You cannot mess these ones up. We give them to you, so do make sure that you do the right thing and copy them correctly. So please, that's one of the mistakes that we've seen in the past. Matrix, copy the formulas wrong. Do not copy the formulas wrong. Now, the second thing is incorrect substitution. Imagine if I had a case like this particular situation here. I've got a Cartesian plane, and I've got a point here, and I've got a point here. We'll call the first point, point A, and we'll give it coordinates -3 and 2. And we'll give the second one, point B, and give it coordinates 4 as well as -1. So what we have noticed that people do not copy the coordinates correctly when they are substituting, okay? Like imagine if I ask you, for example, let's say I'm asking you to work out the gradient. We know the gradient formula is changing y over changing x. One popular mistake could be you copying that formula incorrectly or writing it as changing x over changing y. That is a mistake, okay? So please don't make that error. Now, when I ask you for the gradient of AB, you cannot say the gradient of AB. We know it's going to be changing y over changing x. So it's going to be y2 take away y1 over x2 take away x1. Your y2 is 2. And then you want to take out your y1, which is 1, divided by your x2, which is going to be -3 minus 4. That implies that we've got a problem here. Okay? We've got a problem right over there because we don't know, is that the minus of 1, the number, or is that the minus of the formula? Because the formula also has a minus sign. So it will be very, very important for you to make sure that you actually use brackets. So the correct substitution would be to just take y2, subtract y1, and divide it by x2, subtract x1. What is y2? Your y2 is 2, your y1 is -1. So that will actually imply that when you multiply the negative here, this is going to change to a +1. So just be careful of those kinds of problems. We see these all the time. Incorrect substitutions in the formula, you cannot mess that up. You've got to know your basics, you've got to know your theories, and you've got to know all the ideas and the concepts that we're testing you on. They're not complicated. If you have challenges, we've got a lot of things we've done for you. Go and find us on YouTube. You'll find lots of ideas that will help you to understand how to actually work out these things. So this will be the correct way of substituting, okay? Please do make sure that you understand this and you're not making mistakes with substitutions that are incorrect substitutions in the formulas. And this also applies when you're using the distance formula. Some people will use the distance formula, but when they are subbing stuff up, like for example, if I was looking for AB, okay? If somebody asks me to work out the length of AB, we know it's x2 minus x1 squared plus y2 minus 4. So it's x2 minus x1 squared plus y2 minus y1 squared. That's the distance when they ask for the length of the line AB. So if your x2 is -3, you can go -3 minus minus 4. So that's x2 minus x1. I want you to acknowledge the fact that if you went to the y values and you did y2 minus y1, you will have made a mistake because you did not subtract -1, okay? There's a problem. If this minus is the minus of the formula, it will imply that this minus is also the minus of the formula. And that 1 there is incorrectly substituted. You need it to be -1 so that it will change to +1 when you simplify. So please be very, very careful of that. Now, the next thing is equations of lines. Now, most of us know how to work out the equation of a straight line. I think by this time you should know that. When you look closely at the following problem, sometimes you guys are unable to read the gradient. If I gave you y as 3x plus 4 and I ask you, what is the gradient of this line? I think you will all tell me that the gradient is clearly there. The gradient is going to be +3. But I don't know why, but for some weird reason, some of you guys struggle to work out the gradient if the equation was given in this form. Suppose I say to you 5x plus 4y minus 7 is equal to 0, and I ask you for the gradient of that particular line. You would not know it. Why? Because people will try and subtract 5 and add 7 on both sides of the equation, they'll have 5x plus 7. And then someone will come to you and say to you, well, that's the gradient. Is that the gradient? That's your m? No, it's not. Okay, very, very important. It's not going to be negative 5 because the equation is not in the standard form. What you would need to do is then divide every term by 4. You're going to have 5 over 4, x plus 7 over 4, and then come back to me and say to me, voila, there's your m. This is the correct m value. Negative 5 over 4 is going to be the correct gradient value. So when the equation is not given in a y is mx plus c form, there are people who struggle to work out what the gradient is going to be and use it for whatever reason. So it's a common error that you see almost all the time. So please do make sure that it does not actually apply to you. Now in closing, when you're dealing with circles, okay, equations of the circles, we know what the equation of a circle is. We can be able to figure it out. Just that when you're dealing with circles, they're not that complicated. You will have a Cartesian plane, and you'll have a beautiful circle that has a center somewhere with some random radius, okay? We all know this. We all know that the equation is going to be x minus a squared plus y minus b squared equals to r squared, okay? You can be able to work out what the coordinates of the center are going to be or what the length of the radius is going to be. However, if we start asking you to work out the equation of the tangent, suppose I put my tangent here. Suppose I put the tangent here. You know that the tangent is going to always be perpendicular to the radius. Now, grade 12s, if you're going to borrow from Euclidean geometry, any ideas that will help you to work out this equation of the tangent, because maybe you've got the coordinates of the point of contact and you want to make a claim that these are perpendicular, okay, that there requires you to put reasons, okay, reasons why you would want to say that the tangent is going to be perpendicular to that particular radius, okay, very important. You have to give reasons, and I think we all know that in this case you will claim that the gradient of the radius multiplied by the gradient of the tangent should give you -1. And the reason is because a tangent is perpendicular to a radius. So most people do not put this here. And it's very important for you to make sure that you do not neglect putting reasons where you're going to use geometry reasons in trying to figure out the solution. And maybe in last thing that I want to say to you is that you guys have to be aware that when you're dealing with geometry, when you're dealing with polygons, okay, when you're dealing with polygons, maybe there might be a triangle there or there might be a quadrilateral there. It's super, super important for you to acknowledge the fact that for triangles and quadrilaterals that you're going to get, you have to know the properties of those. And if somebody says to you in the love letter, the opening statement, that you have a parallelogram and you want to use that parallelogram, you will have to provide the reasons. Parallelogram is actually a very powerful thing. Maybe the key important triangles that I want to draw your attention to is that in an isosceles triangle, we'll have 2 equal sides, and that means the angles are going to be equal. And then in equilateral triangle, aka equiangular, we'll have all angles that are equal to 60 degrees, and it's actually also going to have all sides equal. And then a right angle triangle, aka a right, will have an angle that is 90 degrees. Then a parallelogram will have opposite sides parallel, we'll have opposite sides equal, we'll have diagonals bisecting each other. So if somebody gives you this information in the love letter, the opening statement, in the context of analytical geometry, this should mean something to you, okay? And if you're going to use the idea, you have to provide the reasons. What I'm fighting for here is a reason. Why you're saying something is what it is. Maybe if you're saying 2 sides are going to be equal because they're opposite each other, and somebody told you that you're looking at a quadrilateral that happens to be a parallelogram, you have to provide a reason. So you have to know all the properties of polygons, and you have to provide reasons when you're dealing with these questions. So very, very important for us to make sure that we don't fall prey to this interesting problem that we see generally almost all the time. Maybe in closing, just remember the following very, very important key, that geometry, whether it's analytical or Euclidean, geometry, okay, questions are stories, okay, they are stories. If I'm doing question 1, the reason why 1.1 is 1.1 is because it's easier and it's going to help me to answer the follow-up question. So 1.1 is easy, 1.2 it relies on 1.1, 1.3 relies on both 1.2 and 1.1 and 1.4, etc. So remember what you have worked out as you're moving on to try and finding the answers to the next questions. And do make sure that what you have calculated assists you to be able to figure out as you go down the questions and try to find the solutions to the other questions. If you get stuck, always ask yourself a simple question. What was the reason of asking me the above questions? Is there anything that I can do to try and help myself to figure out the solution that I'm currently, of the problem that I'm currently dealing with by using what I have done in the previous questions? We're still coming back with a lot more. Don't go anywhere. We'll be right back.